Many carbons? How many hydrogens? Okay, so what I've just written down is the molecular formula. Meaning flat on the page, and you just show. When you do these, I strongly suggest you draw your carbon chain first. So there's your carbons. How many bonds can carbon make? 4. So each carbon should have 4 lines coming off of it. Because this is an alkane, it only has carbons and hydrogens. So these are hydrogens. So this is the structural formula. Oops. So this is the structural formula for butane. When you hand work in, it must contain all the hydrogens. You can't just throw sticks in and have it be done. Okay? When you submit work to me, it has to show all the atoms. I might forgive 1 hydrogen missed here and there, but I won't forgive 5 bonds on carbon. So make sure you know how many bonds there are. Now, Harshal, can you please hold up your bond, your butane? They don't actually make a straight chain. We can draw the straight chain, but they actually bend. So we can do something called a line diagram. A line diagram shows at each end of a line is a saturated carbon. So this structure shows 1, 2, 3, 4 saturated carbons. What's saturated mean?
It's made all bonds by single bonds.
It means it's got as many single bonds to it as it can possibly have. So it is understood, gentlemen, it is understood that carbon number 4 contains 3 hydrogens, as does carbon number 1. And then carbons 2 and 3 would contain 2 hydrogens each. But when you draw a line diagram, you don't have to show them. Is what's an isomer? So your textbook calls these constitutional isomers. I call them structural isomers. Okay, constitutional isomer or a structural isomer is another structure with the same number and type of atoms but a different bonding arrangement. So to do isomers, you actually have to break bonds and reform them, okay? So you have to break them and reform them. Draw your longest carbon chain, put on your bonds. So each one of those carbons has its 4 bonds, and then put on your side group. So your side group happens to be a methyl group on the middle carbon. Now put on your H's. Oops. So the number that the carbon is on, followed by the name of the side group, it's one carbon chain, so it's meth, followed with a YL, so methyl, and then your longest carbon chain was propane. So this, along with butane, are the two structural isomers for C4H10. Now, I've drawn my side group on the bottom. Can I draw it on the top? Can you rotate your methyl group around the carbon-carbon bond? Can you rotate those? Can you freely twist any methyl group? Try it. Can you twist like you're turning on a tap? Yeah. Can you turn all of them? Yeah. So you have free rotation about your bonds. Okay. So here you've got two diagrams representing the same thing. Pentane. Sometimes you'll see in your book they do something called condensed structures, or they'll ask you to write the condensed structure. And all this is it wants you to do the order of atoms, but without showing the actual bonds. So that's the condensed structure for pentane. It shows which hydrogens are bonded to which carbon, but it doesn't show any actual bonds. Why do we call this 2-methyl? 2-methyl what? Butane. Why don't we call it 3-methyl when it's clearly the third one from the left? Harshal?
It's from the shortest way from either the top or the left or right.
Yes, you start counting from the end carbon, so whichever side gives you the lowest number combination. So this would be 2-methyl, second carbon, and then the longest carbon chain is 4. So bute. The ANE tells you that it's an alkane. Take 2 carbons off, and now this becomes 1,1 dimethyl propane.
Isn't it just 2 methyl? Is this 2 methyl butane?
Say that again, Peter? You can never have a side group on an end carbon. What happens here is our longest carbon chain is connected to gather 4 carbons. So this is actually not an isomer. It is still 2-methyl butane. Still 2-methyl butane. So where do you have 2, 2, and there's 2 methyl groups, so it's dimethyl propane. So you have to state what carbon it's on, what the side group is, and what your longest carbon chain is each time. Eve? We say it's dimethyl because there's 2 carbons. And there's only 1 carbon, so it's a methyl, and they're both on carbon number 2. So 2,2-dimethyl propane. And you can't make any more isomers for C5H12. What I want you to do is you're going to copy this down as well. So we've got butene. Bond here. We still need to make sure that each carbon has 4 bonds. So the one on the left has 2. Whoops. So now it's got 4. The second carbon has 3. Now it has 4. 1 more makes 4. And then these 2. So there we go. Each carbon has 4 bonds. We put in our hydrogens. When we name this structure, you state which carbon the double bond comes after. So if you're going to number these carbons, you're going to number them in the direction closest to the double bond. So you're going to start numbering closest to your functional group. In this case, our functional group is the double bond. So what would you name this one? Raheel? This would be 1-butene. Your textbook also does bute, because it's 4 carbons, then it comes a 1, and then it becomes the ene. So it's either way, you're saying that you've got a double bond. We know we've got a double bond because the ending is ene. We know we have 4 carbons because it's a bute, and it's a real beauty. And carbon number 1 is where our double bond is. Okay? So we can move that double bond. We can move that double bond between carbon number 2 and carbon number 3. Now, this is where Peter's and Noah's differed. Peter, can you hold yours up again, please? What do you notice about the hydrogens on carbons 2 and 3? They're on the same side. Noah, can you hold yours up, please? What do you notice about Noah's? They're on opposite sides. So this is an isomer, but we call these 2 geometric isomers. These are geometric isomers of 2-butene. These are geometric isomers of 2-butene, or but2ene. It is, but it's IUPAC's new way of naming. But when you get to university, stereoisomers. So their stereoisomer is my geometric isomer. And it just means they go in different directions in space. In geometry, they have a different geometry. These will have 2 different names. On the one on the left, your hydrogens are on the same side. So we call this one cis 2-butene or cis but 2-ene. So cis means the same side. The one on the right is called trans 2-butene because they're on opposite sides, or trans but 2-ene. So here's our longest continuous carbon chain. So how many carbons does it have? How many carbons does it have? 3. So it's prop, but it's got a double bond, so it's propene. And then we've got a side group that's only 1 carbon long on the second carbon. So 2-methyl, 1-propene, or 2-methyl. You'll notice that there's a dash between the numbers and the names. Yeah, that looks like an M. No, you just pick one of those 2 names. There are no N's, so it's called cyclo, and there's 4 carbons. So it's cyclo, bute. Are there any double bonds? Are there any triple bonds? So it is carbon-carbon single bonds, so it's butane.
So then is it an isomer of butene?
It's an isomer of butene because it has 4 carbons, 8 hydrogens. You have to have the same number, okay?